Hello friends, welcome back. In this video we are going to study a new program, and it is to check whether number is prime or not. It is an example of a break statement and as well as a loop. So let us see what is prime number. I hope you know it. See, 3, 2, 5, 7, 11 are what? Prime numbers. Okay, and 4, 6, 9, these are what? These are not prime numbers. Okay, and so on. Remember this thing. Now, what is the difference between these two set of values? I said that these are prime numbers and these are not prime numbers. If you observe here, these numbers are not divisible by any other factor, whereas these three numbers, as I listed here, are divisible by other factors also. Means it is 4 is divisible by 2, 6 is divisible by 2 and 3, 9 is divisible by 3. Means we have to find a number, or we have to check that whether my number is divisible by any other factor or not. Okay, means if I consider 5, what can be the factor of 5? Always remember that factor of any numbers are always less than that numbers. Means factor of that number can be 1, can be 2, 3, 4. Okay, and as you know, every number is divisible by 1, whether it is prime or whether it is not prime. Every number is what? Every number is divisible by 1. So what we will do, we will skip this part. Okay, means what factors remains? 2 to less than that number. Means you can say 2 to n minus 1. So n can be any number. I hope you got this. Means what we have to check? We have to divide that number by all its factor from 2 to n minus 1, and if it gets divisible, then my number is not prime. And if it is not divisible by all the factors, then it is prime. I hope you got this. And what I said, we have to start with 2 to less than that number, and we have to check fully divisibility. Now what do you mean by fully divisibility? Fully divisibility means what? If I divide that number by this factor, remainder should be what? Remainder should be 0. So for that we have to use mod operator. What we have to use? We have to use mod operator. Now 5 mod 2, what is the answer? See, look at here. 2 2s are 4. So what is the remainder we get? We get 1. Similarly, in case of 5 mod 3, what is the remainder? We will get remainder 2. In case of 4, 5 mod 4, what is the remainder? Remainder is 1. Means always it is non-zero, and we're done with all our factors, that is from 2 to n minus 1. In this case it is 2 to 4. Okay, so this indicates that my number is what? My number is not prime. But if we consider the case of 6, what can be the factor of 6? From 2 to 5. Okay, so is it divisible by 6? Sorry, is 6 divisible by 2? Yes, because if you take a mod of 6 by 2, you will get remainder what? 0. Here only you get a remainder 0, and therefore there is no necessity to check these cases further, because what happened for 3 also, it will show it is divisible by 3, but for 4 it do not show that it is divisible by 4. For 5 also it is not divisible. So here what we have to do, once you got a factor, once you got that factor which is divisible, in that case you will ignore rest of the cases. You will never check for this part. You will never check for this part. So here what we have to do, once we got a factor for by which my number is divisible, you will terminate your loop forcefully, because there is no necessity to check further. And here in this case, since my number is not divisible, I have to check for the next factor also. Okay, till that number get till that number is less than that number. So if I say this is my n, let us call this as I. Let us call this as I. And what will I do? If my number is not divisible by I will increment my I by 1 till my number is less than what? N. So let us write a code. So here I'll say for I is equal to 2. As I said, we have to start with 2. 2 to less than that number and I plus plus. Okay. Now let us check whether number is divisible by I or not. Fully divisibility is checked by mod operator and my remainder should be what? 0. So we take a mod first, or mod will be taken first, and then after it will be compared with this 0. And if this condition satisfies, as I said, there is no necessity to execute a loop further. So break from the loop. And if this condition fails, then my loop continue to run till i's value is what? Less than n. Okay. But till now, we didn't print any message. Basically, we want to display the message to the user, whether my number is prime or not. If I print that message in the loop, what happened? That message get printed repeatedly, and I want to show that message only once. So definitely, we have to print that message outside the loop. But how you can determine whether my whether my number is prime or not? And it is to be determined outside the loop. So what we can do here, let me rub this part. See, let us take 5, 2, 3, 4. These are the factors. This is my n, this is my I. See, your n is not divisible by I, right? So your I value get incremented. N is not divisible by I again. So your I value get incremented. Again, your n is not divisible by I value get incremented. Now new value of I is 5. Okay, but here what happens once it comes here? The value of I and value of n are same. I value is not smaller than n. So your condition evaluates to false and you come out of the loop. Now let us consider a case of 6. So the factors are 2, 3. Other factors that we want to check are 2, 3, 4, 5. Okay. So this is n, this is I. Is it divisible by 2? Yes, it is divisible by 2. So what happened? These cases, these 3 cases will never executed, because what we wrote here, if it is divisible by 2, or if it is divisible by I, what we have to do? We have to break from the loop immediately. So as you can observe here, when we break from the loop, the value of I is always smaller than n. And when our full loop executes, which means my number is prime, in that case the value of n and I are what? Same, because here in this case my loop executes till my loop condition evaluates to false, and here my loop get executed partially, and that's why the value of I is always smaller than n. So this condition will help you to determine whether your number is prime or not. So here outside the for loop, what will I do? If my n and I both are same, if my n and I both are same, so I'll print the message that my number is what? Prime. And if it is different means definitely it is going to be smaller, so I'll say not prime. So I hope you got this. Sorry, it should be not prime. Now let us dry run this program for 5 and 6. Okay, so the value of I is 2. 2 is less than 5. Yes. N mod 2. Is it 0? No. So what it does? It will increment the value of I by 1. So the new value of I is what? 3. Now n mod 3. Is it 0? No. So condition do not evaluates to true. Again it will goes here. The new value of I will be what? 4. So is 4 less than 5? Yes. Condition evaluates to true. Again it will come here. Is 5 mod 4 0? No. So again no break statement will be executed. Again it increment the value of I by 1. So value of I is what? 5. Loop condition will be evaluated. So 5 is not less than 5, it is equal. So my loop condition evaluates to false. Then it will come here. Now the value of n and I, as you can see here, both are same. So the prime number message get printed. Now let us check for the 6. So is 2 less than 6? So the first condition get checked. Yes, it is less than. So it will come here. 6 mod 2. Is it 0? Yes. So the answer is 0. So it will come inside the if. Since there is a break statement, it immediately terminates the loop and it will truncate or come outside the loop. Now here value of n and I will be matched. Is it same? No. So it will come in the else part and it will print the message that number is not prime. Okay. So I hope you got this. So let us run this program in code block. So there are two variables n and I already declared. So let us write for loop. So for I is equal to 2, we have to go till less than n and I plus plus. Now inside the for loop, I have to check fully divisibility and it is checked using mod operator and by comparing it with 0. So let us put a break statement here. Now that's it with our for loop, and here we will check the value of n and I. So if it is same, then my number is what? Prime. If it is different, means if it is smaller definitely, then my number is not prime. So if you are not familiar with if and for control structure, please watch the video of for and if control structure. I already covered this part and I uploaded that video also. So let us run this program and let us check for the 5 and 6. I'll enter 5. Yes, it is prime, so it is working. So let us check for the 11. 11 is also prime. Okay. So let us check for the 6. So it should show me the message that it is not prime. Yes, working. Let us check for the 9 again. Yes, it is not prime. So I hope you understand this. So please write the program and try for the different values. Thank you.